All right. Net 223 Cisco routers. We're really talking about routing and switching. Monday. We're on week 10, believe it or not. Dynamic and static routing. We started off, we talked about IP addressing, variable length subnet mask, classless interdomain routing. We mentioned about creating subnets and being able to summarize networks. And there is some lab work that we've done or are doing on the summarization. So we answered a few questions about that. And then we talked a little bit about the OSI model. And the layer we're working at right now is a network layer, which is fairly simple. Router gets the routing device, gets a frame, strips the framing part off, looks at the packet, looks at the destination. If there is an address in the table for the destination, it queues it up for that interface, sets it out. And if you can't find an address, then it'll look at the default gateway and send it out that. If that doesn't exist, then Bitbucket drops it back. So we looked at how does the router build a routing table. And so we reviewed static and dynamic. And then we talked about routing protocols for dynamic. And the students listed. So they listed EIGRP, OSPF, RIP, IS, a little hard to see there, that's IS, and then down below is BGP. And then we talked about a number of things which we'll mention in a minute. But routing protocols. So routers are going to exchange information in order to learn about other routes. Okay. We mentioned also a little bit about protocol in terms we were talking over here. We talked a little bit about the data link layer. Is it a LAN? Is it Ethernet 802.3? Are we communicating in wirelessly to an access point 802.11 in order to put that onto the framing with the MAC address and so forth. Now if we're talking about layer 2 here, we have some means of sending it across there, which also happens at that data link layer. And we learn more about that later on, WAN protocols. So let me talk just a little bit about these routing protocols. So we emphasized a couple things. We talked about the metric, bandwidth, load, and so forth, OSPF cost, talk about bandwidth, hop count for RIP, ISIS, path vectors for BGP. The type of routing protocol, we're talking about routing protocols. Here, distance vector, they learn information from their neighbors. So if we're looking at this example up above, this router will learn its information from that router, distance vector. That router learns its information from those two routers. This router learns its information from that router, and that router learns information from this router. We'll talk a little more about that, distance vector. Now, link state, the routers gather information from everywhere. So this router, let's just say, right here, it would gather information from everywhere. And so what it does is it gets a map of the entire network. Okay? RIP, distance vector, learns from its neighbor. ISIS, link state. BGP, really path vectors. I wouldn't even call it either one of those. Border gateway protocol. And then how do these routers know when information's occurring? I mean, when something changes. So they get updates. EIGRP has triggered updates, so does OSPF, whereas RIP has periodic updates. They come on a regular basis, like every 30 seconds or whatever it's set at. Okay? So, routers need to converge, so let's just say this router is going to get information. If we're using RIP, it'll get information from this router, and this router. They'll share their routing tables. And then it'll take the information from the routing tables and put it in its routing table. Now this network here, this router, it'll learn from this router. So it gets its routing table, so it learns about this LAN, and it puts it in its routing table. Then it shares its routing table with this router over here. Now this router can see this LAN can be found somehow through this router, so it can put in its routing table that LAN and say go here to get to it. This router knows where to send it. It says go down here to get to it, and this router is directly connected. And then they indicate those differences by hop count if you're running RIP. Alright. A couple more things. We talked about OSPF learns about the whole network, well, it does it by areas. So we have an area 0. There can be, so many whatever number of routers communicating, and then there's connect other areas to it, like an area 1, area 2. Maybe this is 3 and 4. And then if you do a good job with your addressing to summarize routes, this works very well. Then we worked on the lab. And I sent an email with a podcast talking about the lab. So this is the lab for RIP. And, whoops. For RIP. And we sent the students that were in class today were able to get this done. Maybe not quite completely. There's a few other things we need to do. Alright? And so that's a review of today.